Welcome everyone. So in this video, I'm going to show you how to find absolute maximum and absolute minimum values of a function. So these are the two examples I'll be working on. Now, before we dive into the procedure, I do want to show you which method we're going to use to find these extreme values. So this is what we call the closed interval method. So pretty much the idea is to find absolute extrema, which is absolute max or absolute min. So this is just another word for absolute max and absolute min values. So we call them absolute extrema. So finding absolute extrema of a continuous function on a finite closed interval. So this is the closed interval method. First thing you want to do is find all critical numbers or critical points. So critical points is when you take the first derivative of that function and set it equal to 0. You get some x values, those are the critical numbers, and we're only going to look at within that interval. And then once we have them, then we're going to evaluate the function at all critical numbers within that interval and the endpoints of that interval. Once we have step 1 and step 2 completed, then we'll test step 3, which is to pick the largest and call that the absolute max, and the smallest would be the absolute min values of that given function within that closed interval. So hopefully you got an idea down. Now let me show you how we're going to do that for this particular example. So I will put it down here and then we'll work it out. So step 1 is to simply find the derivative and set it to 0. So those are the critical numbers. So we're going to find the derivative of this function by using the power rule. So for this one, I bring down the power, subtract 1 from the power. That is 2 times 3, that's 6, x squared. For the second one, we do the same thing, power rule. That's 6 times x. And for the last one, we take the power rule of negative 12x, we have negative 12. And the derivative of 1 is 0, so we don't need that term. And then the second, we take the derivative, we set it to 0. So that gives us 6x squared minus 6x minus 12 equals to 0. And if you want, you can divide everything by 6. So you will have x squared minus x minus 2 equals to 0. So now you can use quadratic formula or factor. Looks like this is factorable. We get x minus 2 and x plus 1 equal to 0, which means we get x equal 2 and negative 1 as our critical numbers. All right, now you have to make sure that these numbers are within the given interval in order to use the closed interval method. So 2, yes, so x equals 2 is in there, check, and then x equals negative 1 is also within that interval, so check. So both of these are within the interval negative 2 to 3, so we're going to test both of these along with the endpoints. So that is step number 2 from this closed interval method. So we're going to test the critical numbers. So f of 2, we plug this into the original function. You have 2 times 2 cubed. So that's 2 times 2 cubed. Negative 3 times 2 squared minus 12 times 2 plus 1. So I'm simply picking my critical number and plugging it in right here for the x values. We're evaluating the function at that point. And then you can use a calculator to evaluate this, or you can just do it mentally, work it out. So this will give you 2 times 8 minus 3 times 4 minus 24 plus 1, which is about negative 19. So that's one of the value. Then the next one we're going to test is the second critical number, that's negative 1. So that's 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 1. And if you calculate this, you'll get 8 as your final result. And now So these are the tests on the critical numbers. Now we test the endpoint. So we're going to test -2 into the function. We plug it in. And so we want to know what is the value of the function at -2. So it's 2 times -2 cubed minus 3 times -2 squared minus 12 times -2 plus 1. And this will give you about -3. So one more to go. The last endpoint of the function, which is this one right here. So f of 3. F of 3 is 2 times 3 cubed minus 3 times 3 squared minus 12 times 3 plus 1. And that will give you -8. And now you just compare them. So the last step right here for the method, you take the largest, that's your absolute max, smallest, the absolute minimum. So among these four, we see that the largest we have is this one right here. So that's the largest value. So f of -1 is the absolute maximum, and the smallest is this one right here. So f of 2 is the smallest, -19. So we can say that, therefore, by the closed interval method, our absolute maximum value is 8, and absolute minimum value is -19. Now let's go ahead and try this second example. So we'll do the same thing. We'll find its first derivative and set it to 0. So the first derivative here, we're going to compute by using the chain rule. So the chain rule is to simply use the derivative of the outer function times the derivative of the inner function. So you can think of it as a u substitution here. So you can do this by a u substitution. Let u be equal to x squared minus 1. And then your derivative of u respect to x is simply 2x. So then your function, f of x, will become f of u, which is u to the third power. Then the derivative of u is simply 3u squared times u prime, or you can say du dx. So let's go ahead and rewrite this in terms of x. So our f prime of x is equal to 3u. Well, u is x squared minus 1 squared times du. That's 2x. And just clearing things up, this is 6x, 3 times 2x. That's 6x times x squared minus 1 squared. And now we take the derivative and set it to 0 to find the critical numbers. So that is 6x times x squared minus 1 squared equal to 0. So 6x equals to 0 gives us x equals 0. So that's one critical number. And then we take x squared minus 1 squared equal to 0. You can square root both sides, get rid of the square, and solve for x. You get x equals plus and minus 1. So these are the critical numbers for this function. Now we're going to find the function value at the critical numbers and at the endpoint. So we'll find the function value at 0, then we'll find the function value at 1, and then at -1. And the last one would be the endpoint. So this has already happened to be an endpoint. That's fine. And the next endpoint is this one, 2. So we have f of 2 to evaluate. So let's go ahead and do that. So if I plug 0 into my original function, I will get the following. So if you plug in 0 into the original function, you get 0 squared minus 1 cubed. So that would give us -1 cubed, which is -1. Now when you plug in 1 into the function, you get 1 squared minus 1 cubed, which is 0 cubed, that's 0. And when you plug in -1, you get -1 squared minus 1 cubed. That is again 0 cubed, so that's 0. And the last one we're plugging in is 2. So that is 2 squared minus 1 cubed. That's 4 minus 1 cubed. That is 3 cubed, which is 27. All right, so now we're ready to compare them. So plugging in the endpoint and the critical numbers into the function, the largest value we obtain is this one. So that would be the max at 2. And the lowest is this one right here. So we can say that, therefore, our absolute max value is 27 and absolute minimum value is -1 for this given function.